Okay, so I have worked on the task student score predictor on the dataset provided by the Sparks Foundation. So what you can see here is a Google Colab notebook, which I've used for creating the linear regression model based on the dataset provided. So on the right hand side here, you can see that I've opened the CSV file, which was given as a dataset. So it's a very simple and straightforward file. It has like two columns, R's and scores. And as you can see that it has only 25 samples. So it's a very small data set. And using this data set, I've tried to create a linear regression model. So I will just go through the code also, what I've done here. So, so first of all, I've imported all the required libraries for the project. Like I've imported pandas, I've imported numpy, then matplotlib, pyplot, which is used for plotting the graphs. And then I've used primarily for the modeling, I've used scikit-learn. So I've used the cross validation score, k-fold, and I've used the linear regression. So as it is a small data set, so I've used the cross validation just to create more accurate model. So if you are given a small data set, you can make use of cross validation technique just to make sure that the model which you are creating, it performs well on the training data set as well and on the unseen data as well. So yeah, so these steps are quite basic steps. So the file, I've uploaded the file here, studentscores.csv. So I've just giving the file path in this particular line of code. Then I'm just loading that CSV file into a pandas data frame. So you can see the pd.read here CSV code line I've used for that, and just checking first few rows of the data just to make sure that it's all good. And after that, checking for any null values, if there are any null values in the column files. So this is a very clean data set. It's a very small but clean data set, so it has got no null values. And then some summary statistics also, like how many records are there, what is the mean of R's, what is the mean of scores, what is the standard deviation. So as you can see that there are no outliers, as you can see from the statistics. The data looks like normally distributed here, so it looks all good. And after that, I've just tried to visualize the data set just to check whether there is any relation between hours studied and scores which students have scored. So it looks like a very strong correlation. It looks a linear correlation as well. So as we can see that as the number of hours are increasing, the scores are also increasing. So looks like linear regression will be a right kind of model for this kind of a data set. So just to verify the cross verify this relationship, I've also tried to compute the correlation between these two columns. So as we can see, the correlation score is quite high. So it's 97 0.97. So this is a strong correlation. So we can go ahead and create a linear regression model for sure. The next step was just to prepare the data for modeling. So as we know that the linear regression model expects data in a certain format for it to create a model. So I've just created this line of code. So I've just extracted the x, I've just extracted the r's column into the x variable here, which is a feature column, and I've extracted the scores into y column, which is the target column here. And and after that, I've just created the k-fold, as I mentioned that I will be using cross validation for creating the linear regression model. So I'm just creating 5 splits out of the data set which is being provided. So that means that the data will be trained 5 times, and each time it will be using like different combinations of training and test data set out of the given samples. So I've also shuffled the data set just to make sure that if it's not if there is not a proper distribution of data, so we shuffle the data so that there is no bias introduced within the data set. So removing any bias basically. And here I'm creating the linear regression model, a very simple command for that. And after that, I'm just trying to score the model which was created in the above line of code. So it's again passing the model into the cross val score function, passing the training variable and passing the independent variable and the dependent variable using k-fold as CV, and I'm using the r squared score for scoring the model. And finally, I'm just printing the scores. It looks like the mean r squared score, the average r squared score is 90%, which is not bad, which is quite good score. And after that, I'm fitting the model on the independent and dependent variables here. So here we are actually fitting our model to the variables which have been provided in the data set. And final step is using the model which has been created. So we are using that model to create predictions for new data. So I'm just trying to understand that what score will be. We were just predicting score for 9.5 hours of study for a student. So I'm just passing the 9.5 to the model.predict function here. And as you can see that the model is making prediction of 95 score for 9.5 hours of study. So it's very straightforward, very simple model which I've created. And yeah, so hopefully if you have any comments, any feedback to share on this code, on my approach, so please feel free to share that. And thanks a lot for watching. Thank you.